Okay, so in this video, we're going to distinguish between field forces and contact forces. So basically what happens is a force, right, is a push or pull on an object. Before, we were really calling these are the interactions we were kind of speaking of, right, up above in the previous videos. We were just talking about how like things interact. Okay, well, the interactions that they show are these forces, okay? And what happens is all the forces we will discuss will fit into one of these two categories, a field force or a contact force. So the first one, so contact forces, right, they come from the interaction of objects in contact with each other. So this is when we do have kind of physical touching between the forces, right? So that's what we mean by contact, so physical touching. Most of the forces that we will look at or that we'll encounter will be contact forces. Okay, there's only really three main field forces that we'll talk about. So one example, you push, right, a crate on the floor. Right, so the only way that that crate will change its motion is if you physically push, right? So you have to physically touch to push it, okay? Another one would be on the other end, right? Because remember, force is a push or pull, right? You pull and wag. So what you're pulling with, right? Right, because the force that you pull with, that would be a contact force, okay? Now, on the other hand, forces that act at a distance, right, are from interactions between two objects that are not touching, okay? And these are what we call field forces, not force field, although that would be cool to have a force field, but field forces, right? So the important thing is that field forces come from when objects don't touch, they're not touching, okay? And really in physics, in the universe, there's three main field forces, right? The gravitational force, which we spoke about in the last video, right? This is that pull from the Earth or the planet. The second one will be the electric force. Okay, there is an electrical force that exists between two charged particles, and then a magnetic force. Right, so think about that the Earth also has this magnetic field that goes around it. But the key idea with field forces is that you have a central object, right, with, you know, this field that sits around it, okay, and then once objects enter that field, right, so this would be like, you know, gravitational force, right, this would be an example of gravitational force. We talked about that earlier, okay, right, it wants to go into the Earth. Now, on the other hand, if I have kind of a, you know, if I have a charged particle, right, a plus or minus, this is going to be dependent on, right, so in fact, the field lines for positive go away from it, okay, the way electric force goes out of positive into negative, okay, and so the second, you know, if I have a negatively charged particle, it's going to try to go into it, and if I have a positively charged particle, it's actually going to flee away from it. Okay, remember, these two both act with opposites attract, likes repel, right? And that's why they actually get lumped together into a big force called the EM force, or electromagnetic force, okay? Because they display very similar properties. All right, so now let's just talk about some different forces, okay? So the first one, we've mentioned this one before, right? This is really the only, at this point in time, the only field force we're going to talk about, so S of G. All right, and we defined it in the last video. It's really the gravitational pull. All right, so it's the gravitational pull from a planet. I like to use the word planet only because what happens when they throw it out there that it's done on Jupiter. right? And if someone does all their work on from Earth, they're not going to understand how to handle, that. Okay? The only thing is that you would need to know this value for the G value for the different planets. Okay. The next one is just simply what we call an applied force. And the way you can see this table is broken up is what the force is, the symbol for that, and then just a little bit of a descriptor. Okay. So the symbol for applied force is FAPP, right? And this is just a force that is applied by just a physical force, force exerted by a person or another object. Right. So if you pull on the wagon, you're applying a force to the wagon. If you push on the crate, you are applying a force on that crate. Okay. The next force is what we call normal. All right, so the normal force. So F sub N. This is just simply a support force from a surface. Right, the one thing about it always acts perpendicular to the surface. In fact, in math, there's a term called normal. If I ask you to draw a normal to a line segment, what you're going to do is you're going to draw a perpendicular line to that line segment. Okay. Next one is tension. I would say this is F sub T. And simply tension is the force exerted by strings, ropes, cables, right? Force exerted by strings, ropes, cables, or anything like that. Okay, the main thing is that these materials are what we call inelastic, right? They don't want to stretch. The stretching force, or the stretching piece, comes from what we call the spring force. Okay, and I know I'm kind of flying through a lot of this, but right now we're just going to kind of define this stuff, and then later in videos we'll adjust specific forces and how we do problem solving with them. Okay, this is the force exerted by a spring on a mass, right? Or on an object is what we should say. Okay, and then it obeys what is called Hooke's law. And for the most part, if tension is in inelastic materials, spring force is in elastic materials. Okay, and then the last one is kind of the big one, and we'll spend a fair amount of time talking about this force. It's friction. Okay, we get a lowercase f. Okay, and now this is a surface-to-surface force. All right, it opposes motion. Okay, in fact, it's parallel to the motion, which means it's vertical or horizontal. And it also, and so in the next video, we'll just, start talking about Newton's laws. And we'll go from, and then, so we're going to talk about the first and third law here, and then the second law we'll tie with dynamics into the rest, once we do the second topic. The first topic to me are just our water forces, and then Newton's first and third laws. And then the second topic is what we'll focus on Newton's second law and problem solving, okay?